VCF 50 exhibitor tape number 1.
Well, howdy. Two of us worked on some programs. I happen to be the last one here, Steward. And the motivation for this was that in the Computer History Museum, we have, I want to call it a bicycle chain machine that was made by Lamer. And he used it to factor big numbers. So I thought a novel exhibit here would be to make a mini chain machine. And I went and bought these chains and thought I could do it very simply, but I had a problem. It turns out there's a mechanical problems with the chain.
Uh-oh.
And so that doesn't work perfectly.
So the mechanical problem was that it can only have an even number of...
The chain probably wraps up around. That's the mechanical problem. There was another problem when I had the chains made. He can only make an even number of links. I wanted prime numbers. I wanted 16, 17, 19, and 23. All of my chains except 16 got to be one link longer. And that's why on this, I don't know whether you can see it or not, my chain lengths are actually 16, 18, 20, and 24. But nonetheless, it turns out it still works.
Oh, good.
Mathematically, I can't explain why. But we set it up and run it, and the technique is based on factorization of numbers. It was originally done by Fermat, the mathematician who's got a very famous last theorem. And he discovered that it was much easier to generate squares and detect whether a number was a square or not than it is to do a long division. Turns out to generate a square, all you have to do is add consecutive odd numbers, and you get consecutive squares. And that's the basis behind these formulas.
Oh, neat.
How much longer do you want to go?
Can you just give us an explanation of what's going on your laptop?
Okay, on the laptop, I have set that up for a demonstration, and to make life easy, I call that D. And at D, you type in a number that you want to factor. I'll use the one that I've used here quite a bit. That is 15 million. And I allow spaces between the digits. 831. 653. Hopefully I haven't typed that in wrong. I'm making a little concession here. I programmed an operator in another arithmetic program to use that as a starting number and calculate what Lamer would have needed to figure out to set up his chains. This number here is the square root of that number raised up a little bit, so it's bigger than the number. This number here is what you get if you take this number and square it and subtract the original number. And this is the original number prettied up.
Right, 15 million.
After I've computed those, I go into a little program that simulates and sets up the chains. And so when I set up the chains, it turns out what we're using here is the chain length 16, 18, 20, and 24. I used vertical bars for the stopping screws. In the one that's over in the museum, you'll see he used little bows to hit microsections. I did this so you could just eyeball see when they're lining up. And you can see that I've chosen a number here so that they will line up when you shift them. Pressing the space bar, you shift the chains. You can see this marching over. And when it gets over to the point that it's going to be detected, it rings the bell at you and says that the number before it was indeed in number systems base 16, 18, 20, and 24. It all fits for being a square. We don't know for sure that it is, but then Lamer would go off to his Monroe calculator, and he owned a Monroe calculator when he died. He would do this arithmetic. He would take the number that it stopped on, which is 3987, which is the number that's shown here. He would square that, and he gets 15,896,169. He subtracts from that the original number. When he does this, he gets the number 64,516. My little four chains thought that number was a perfect square. And it turns out, by golly, it is. It's 254 squared. So now we know what, in these formulas, A is, we know what B is. A is our 3,987. B is 254, so it's very easy for us to do the arithmetic.
Find it.
Add it on. These are the two numbers, and when you multiply them together, you get that number.
Neat.
That's all there is to it. I made one little slide here, and the only thing, you may be able to see that, the only thing germane on this is the very last sentence.
So if we prime the chain so that each step also adds the next odd number. Tricky, but fundamentally very simple.
Very simple.
Yep.
There it is.
Neat. And it's just a plastic clothes basket and some chains and a tie rod.
Shaft.
Yeah, shaft.
Oh, I use for stopping pins, I use little magnetic discs. And hopefully they'll just stop on each, or hang on to each chain. But when I have the mechanical problem, people want to help the chains out and they push these off. So I'm going to have another version that's got longer chains, and hopefully I won't have the mechanical problem.
Next year.
Next year.
Cool. Well, that's perfect.
You tell me when you're ready?
And we're rolling.
Oh, you are? Okay. Well, my name is Paul Zurichkowski. I live in Livermore, California. I'm a retiree from the Atomic Energy Commission. I'm trained as a physicist. And I got interested in computers many years ago when just after World War II, I was a college student and I went to my advisor and I asked him, well, hey, these computers looks like they got a future in them. And he said, no, don't waste your time. You have a whole room full of vacuum tubes. You got to change them every other day. So I took his word for it and went back to my slide rule. And so anyway, when the Mac first came out, why, by that time I really kind of needed to use a computer. So I learned how to use the Mac on my own because it was pretty easy to learn. And so I've been with the Mac ever since. So I have a nice collection here of portables. This is only a very small fraction of my total collection. I have enough to fill that whole back room there, about 4 dozen or so.
So when did you first get a Mac?
I got a Mac when they first came out in 1984. And then I kept getting them after that. And of course, in my work right now, I use the G3 and the G4, but I still don't want to scrap my collection here. I have all kinds of them that are very nice. They all work. The one I'm having a little trouble with is the first portable right here. It was working until yesterday, and now I see it's almost working. It's got lines on it. So I guess I'll have to take it apart and figure out what's wrong with it.
So which one, do you have your first Mac that you...
And the first Mac is right here. It is the first Mac, the 128K. And then comes the 512. And then comes the Mac Plus. And then my favorite for many years was the SE30. As a matter of fact, I still use it in my telescope workshop. I keep all my optics on it. And it's been going great ever since I first got it when it was new. And it's never broken down even once in all those years. So I have a lot of respect for Apple engineering because they know how to make one. And that next one is a favorite of the Japanese. It's a color classic. And you can see it's small, but it's got a beautiful color screen. And the Japanese are famous for liking little things like that. They don't like great big, they have small homes and small rooms, and that's the way they like to live. And so that was a very good selling computer to the Japanese. And the next one over is the Mac TV.
That's the black one.
That's a black one. It's a very nice computer. Got a beautiful color screen. It's not on right now. I could push the button, it'll start up. But it didn't, I guess it wasn't really popular in this country, but students liked it for a while because they had a TV in their college dorm right along with their computer, so they liked it for a while. And then I have a whole collection here of duos, starting with the first one, the 610, and then I end up with the last one, which is a 2300, with a duo dock, and then I've got a mini dock and a mini dock that goes with those, and they all work fine. And then these right here are the first computers, the first portables that made Apple famous. The first, I call them the first world-class power books, because they really were. The 140, the 170, and the 180C was a really expensive one, but it was a very nice one, and a very nice color screen on it. I think it ran over $6,000 when it was new, though. But the most expensive Mac power book of all is the one over there. It's the 5300 CE. That went for just about $7,500 to start with. And sometimes if you get little extras with it, it costs even more. And the big problem with the 5300, they put in a special battery that was supposed to last twice as long, and turned out that it actually caught fire some of the time, and so people kind of lost confidence in it. And then Apple went back to the regular kind of battery, but it never got popular. But it was a really very nice machine. It was the best in the world when it came out. There wasn't anything that came close to it. So I have them all from the very first one, which got changed by the Japanese, by Sony, to the PowerBook 100, and they don't look like twins, but they really are. Under the skin, they are twins, where the electronics were actually switched over here. So I do have the rest of them at home, but then you can only carry so many things down there, and they didn't have enough tables for all of them. So
Okay, great.
This is my collection. Yeah. So you're with the History Museum here.
Right. And so, Paul, do you have any contact info, like an email?
Yeah, you've been sending me email from time to time.
Oh, so we're on your list.
Yeah. So I was thinking maybe one of these days, perhaps you would be interested in just taking my collection. None of my children or my wife or anything are interested in computers.
Oh, we definitely would be.
So okay. Well,
Okay,
we'll
good.
Keep you guys in mind then.
Okay, good.
Gentleman who is looking for an IBM graphics computer. Hi there, my name is John Lawson. This is my antique DEC PDP-1144 system that was rescued from a company in San Diego where it was in service about 22 years. It was commissioned in late 1979 and taken out of service in April of this year of 2002. It's a fairly well done 1144 system. Two nice 350 megabyte disk drives, a 10 megabyte RLO2, and 1.5 megawords of internal memory. System's running RSX 11. Can support up to 32 users. I think there were 8 attached to it, but the system originally did facilities management, air conditioning, processing, that kind of work for this plant. And contains software that would check on limits, and if there was an alarm, it would actually dial out to people's pagers and page them automatically. If something failed or there was an alarm system, it knew enough to get a hold of folks and say, hello, there's something failing, as well as doing reports. It did a little bit of office management stuff for that particular division, but its general work was real-time process control. So, and the system was set to be scrapped. The person who was the system operator hid it in the basement of the building so it would be out of sight, out of mind, until he found the Computer Collectors Group, got a hold of us. I agreed to rescue the system, and 350 pounds of paperwork later, here it is. So,
was the oscilloscope part of the?
No, the oscilloscope devolves from a long-running thread on the classic computer collectors list about rack mount Tektronix oscilloscopes. Since I had one, I mounted it in the rack when I came up here, just to see if anybody would get the joke. So far, no one has gotten the joke. But the oscilloscope has nothing to do with the system. So.
And so the RLO2 is removable disk.
That's correct.
That top load, so that slides out.
Would you like? Shall I demonstrate that to you?
Yeah, that'd be great.
Okay, you'll stand by. What we'll do is, currently the disk is loaded and mounted. I'll cross in front of it. I'll go over here to the system console, and first thing I will do is let the operating system know that I'm going to remove the drive. So I will logically remove it by dismounting it. I will issue the instructions on the system console here. Okay, so now you can see that the disk has been logically dismounted. This means that the excuse me, that the operating system knows that we're no longer going to be accessing this disk, and it knows enough not to try to access it. The next thing I need to do is to operate the load key. Currently the disk is up and loaded. So by pressing this, we're now spinning down the disk. There's actually a brake in there that's slowing it down. And I'm going to wait for the load light to come on, which takes about 15 seconds for the disk to slow down.
So what's the capacity of this?
These disks are 10 megabytes, this particular pack. So we have a load light now. So I'll pull the drive out from the chassis.
So you just need to make sure you have your legs extended when you...
That's correct, because
you could get excited.
that's one of my little maxims is a computer is not really a computer unless it can kill you if it falls on you. So we'll open this up. This is the bottom of the drive. And we'll remove the disk pack. You can see inside there is one platter, 14 inches, that is rotated by the drive. And it goes in this box, which protects it for shipment. This particular drive on this system is used for software updating and for backups. So incremental backups were done to a set of these disks every day, which kept the data safe.
And then you have two other hard drives.
That's correct. And the two other hard drives are contained in this chassis right here. And you can actually see them through the slots back there. There's a pair of 5-inch Micropolis EDSI drives.
So when you got a new release of the OS, if you have one of these systems, you would get a disk like this?
You would ask for the DEC release their software updates on various media, floppies, 9-track tapes, or packs of various sizes. So this particular system, when you got your update, you would ask that it come on a RL02 pack. So I'll go ahead and reverse this process now.
Okay.
And take the disk out of its... this is a two-handed job, and one hand's full of microphone. We'll take this out. Let me show you, as long as you have the camera out here. This is the spindle right here. This spindle turns. Back in here is the heads, which extend from this particular opening. There are two heads that attach to either side of the disk. So I'm going to put this drive in here like this. Then we lock it down, and that cover goes on top of it to protect it. We'll put the digital logo straight up, and then we'll close the top. Put that back in. Now we'll spin up the disk by pressing the load button, and I'll wait for the ready light to come on, which means the disk is up to speed and the heads have loaded and have found a good disk and good data. Okay, so the ready light is now on. Oops, went back off again. Of course, it's during the interview with this stuff.
Yes. So about how long does it take for it to spin up?
It should have already something. It didn't like something here.
Like a switch is not...
Yeah, there's a switch off something, yeah. I'm going to pull it out and we'll see what's going on.
Okay.
But this is one of the joys of legacy hardware.
Yes. So is there anything special, like final thoughts about this system that makes it special or special for you?
No, it's just that it's a fairly nicely extensible system, and my plans for it are to add various peripherals and devices until it's something on the order that a medium-large company would have used. Mm-hmm. And we'll go from there.
Great.
Okay.
So do you have any contact info, email?
Not particularly, just on the computer.
Okay. Okay, great.
My name's Don Woodward, and I can be reached at woodward@woodward.org. And what I have here at the Vintage Computer Festival is some vintage Xerox equipment. I have 3 machines here. I have a Xerox 6085, and it's running software that was the original Star system. Now, the Star system started development in 1978 and was first commercially released in 1981. The system that I'm running now is actually the next generation, the second generation machine. It's called the 6085, and it was released in 1985. The software here is first released in 1981 and was continued pretty heavy development up till about 1989, 1990, and then sort of slowed down and had a few maintenance releases for a couple years. But what you're seeing as far as user interface is concerned is pretty much true to the original Star. And it's really interesting. These workstations were from the beginning multilingual workstations. So you can see I have a document, a WYSIWYG document. I believe this was the first WYSIWYG document and editor ever commercially produced. Excuse me. And you can see it supports many languages, and it has a real interesting feature. I'll just hold down the keyboard key here, and you can see a little keyboard strip at the bottom of the display. And I'll just go ahead and show the virtual keyboard. And you can see I can switch keyboards to, I have a Greek keyboard, a Russian keyboard, equation symbols, math symbols, logic, legal symbols, Hebrew, Arabic. And in order to do document editing in a different language, all I do is switch my keyboard, and then I'm off and running. And you can see here that, that I've got a document with different languages in it. Now, also something that was unique was there was a WYSIWYG equation editor. And I don't know if you can see it, but you might want to zoom in on the equations. So that was a real interesting feature. But, you know, most people think of this system as the predecessor to the Macintosh, and it was actually not the system that Steve Jobs saw at Xerox PARC. That was the Smalltalk system. This was the sort of commercialization that Xerox did of the technology. A lot of technologies occurring at PARC, such as Ethernet. This has network connectivity built in, and it had a lot of software for network collaboration, such as shared books, where teams of technical publishers, say at Boeing and Cessna, those were big Xerox customers, would collaborate to produce aircraft manuals with these systems. Was one of the primary uses. Another customer, Genentech, caused Xerox to write a chemical illustration software that allowed you to create molecular structures in a WYSIWYG fashion within the document editor. And it was really interesting because it constrained the user to only creating chemical structures that could occur in nature. So there was a lot of interesting technology that went into this. And the reason that I'm really interested in these systems is not so much the desktop metaphor that captures most people's interest, but actually the machine technology. These machines run a programming language called Mesa. Mesa was a language invented at PARC in the 1970s that was based on Stanford Research Institute's modular programming system. And a lot of languages such as Modula, Ada, even Java takes their influence from Mesa in certain respects. Java in the area of threads and concurrency, for example. This operating system is a fully preemptive multitasking operating system. The machine runs a 16-bit Mesa processor, which is actually implemented with 4 AMD arithmetic logic units that run microcode to implement the Mesa processor, so sort of a hardware virtual machine. It runs an operating system called Pilot, which was developed at Xerox in Mesa. And Pilot is an operating system that is really closely tied with the processor and the Mesa programming language. It provides runtime facilities to the Mesa language, And the processor itself, the processor design, has the notion of threads and virtual memory built into the processor. So it's a very tightly integrated system, very interesting technology. And that's really why I'm interested in it, is really for the computer science aspect of it, not the user element. Now over here, what we have is the Xerox development environment. And this is an interesting system because it's also written completely in Mesa. It's based on the base operating system Pilot. It's running on the same hardware, but it's a completely different user environment with a different user interface metaphor. It is a programming system, a whole environment written by programmers for the purpose of developing software. And this was the system that I used for 3 years when I was a Mesa programmer at Xerox, and it's a very immersive environment, and it's a really highly integrated system for developing software. And this is the system that is used for developing the software that was the SAR system.
So are these two boxes basically the same hardware?
These two machines, these 6085s, are exactly the same hardware. They have different sized disks, but other than that, they're identical. The machine in the middle is a Xerox Network server. It also runs the Pilot operating system, Mesa code, with a services boot file, it's called. And Xerox Network Services, or XNS, is sort of the network operating system that Xerox invented. And it runs the XNS Ethernet protocol. There are XNS packets that are going across the Ethernet. And the interesting thing about the Xerox Network Services is they're also very, very highly integrated, and their enterprise strength. I mean, this is back 1981. Xerox created a completely interconnected network of local area networks, the Xerox Corporate Internet it was called, and they were all driven by these network servers. And these servers ran different services. The server I have has a clearinghouse directory service, a file service, a mail service, and a boot service. And the nice thing about services, just to round out the talk, is that the directory service organizes elements on the network hierarchically in terms of name, domain, and organization. It's a three-part naming system, and the names are unique across the entire network and global. So, for example, I can create a group, a mailing list, for example, and I can send email to that group, and I can also use that group to apply access rights to a file server on the network. So this is a level of integration that we still don't have today in our network technology. So this whole combination of this whole system, but primarily the Mesa environment is why I'm interested in this stuff.
That's a great overview.
Thanks.
That's fantastic. Thanks.
Okay, my name is Rick Arrington. My occupation is software engineer. I specifically test software. They make it, I break it. What I brought today is my Silicon Graphics collection. These are computers, all but one of them made in the middle 90s. And this was a line of computers first introduced in 1993. Over here is the entry-level system that Silicon Graphics made at the time called the Indy. Of course, it has a camera on it that they all came with, and it's a Unix workstation. It has one processor, a 200 megahertz R4400, which is a MIPS 64-bit RISC processor.
And that's the processor, the actual CPU underneath there, the green box.
It's the blue box right here.
Box.
One of the interesting things about Silicon Graphics, and it's hard to see in the exhibit here, is they were really out of the box in how they decided to make their computers look. If you look at this one down below, it looks like a pizza box kind of sliced sideways and it slid apart a little bit. It was kind of unique in the way they made computers look at the time. The computer next to it is an Indigo 2. This was a higher-end desktop workstation made by Silicon Graphics at the same time period, also introduced in 1993. This also has the MIPS R4400 in it. This one runs at 250 megahertz. This system also has the Galileo option installed. One of the features of the Galileo option, we'll log back in his root to see it. The Galileo option allowed for digitizing and recording video streams. And this system currently is real-time digitizing and displaying the video stream from the Fellowship of the Ring DVD. The DVD player is here supplying standard NTSC video to the system, which picks it up through the Galileo interface box and is displaying it on the screen. We can actually do frame grabs from the video. And I'm bringing up an example of one now. This is an actual frame grab from the Fellowship of the Rings, captured on the system. And as you can see, it's fairly clean resolution for NTSC composite video.
So what's this box you've got down underneath?
Now this is the big one. This is my favorite silicon graphics system. This is a Challenge L system. It was a restoration project. I purchased two systems that were incomplete and made one out of two. It has 12 R4400 CPUs installed, running at 150 megahertz. It has 1.2 gigabytes of memory installed. This was a higher-end system produced by Silicon Graphics. This model was introduced in 1993, and this particular example was built in 1995. The original owners of the system were Informix, and the parts from both of them are also from Informix. Their name for the system was Video 1, which they had the label on, which I've left on. One of the features of the Challenge system, or the Challenge line, was flexibility. This is a backplane from a Challenge system. The 5 slots on the left are a proprietary Silicon Graphics interface called the Everest bus. The 6 on the right are standard VME bus. The first slot would have a memory board, and a memory board could hold up to 2 gigabytes of memory. However, if you wanted a lot of memory and you didn't need a lot of CPUs, you could have 3 memory boards installed for a total of 6 gigabytes of memory. If you wanted a lot of processors and you didn't need as much memory, you could have 3 processor boards installed like I have in that system for a total of 12. This slot always had an I/O board. And on that I/O board, it bridged between the Everest bus and the VME bus. The VME bus could have interfaces installed on it. The I/O board that went in here also had what they called mezzanine slots. And those mezzanine slots could provide external interfaces. In this particular system, they have SCSI buses installed, but they could be network interfaces. This system could have as network interfaces 10 base T, 100 base T, ATM, FIDI, and HIPPY all at the same time and do justice to all those interfaces.
So what was the bus speed? What did it run at? Do you know off the top of your
I
head?
don't recall off the top, but I believe the Everest bus is 256 bits wide.
Okay, any other final thoughts about why this is such a great machine?
Well, to me, the
Great
machine,
vintage machine.
to me, they were special because when these systems were new, I used to work on systems just like this at work. And I kind of got into working on them. So I waited for the chance to have some of my own to put in my own private collection and use. And I like old computers. So this is my SGI collection.
That sounds good. Okay, great. I'll ask you questions.
Okay, go ahead.
Who are you? What do you do? And where do you live? What kind of contact info? Do you have a web page? And
Well, okay, basically,
you have to just talk into the microphone.
okay. My name is Hans Franke. I'm from Munich, Bavaria. Well, where else? Is there any other place in the world to live? No. Okay, what we have here is Cyber 960, which is a classic Seymour Cray design for a supercomputer mainframe. What you see here is behind the think sign, is a picture of the basement of a warehouse building in Munich, where a friend of mine has his collection. His name is John Sabolitsky, and he got not only this Cyber 960 running, but another CDC machine somewhere in back, and in between the other machine and this machine, behind this tape drive, is a Cry YMP. So this is basically his personal computers.
Where do you get these? Where did they come from?
He collects them over some years. He is basically the biggest, worldwide biggest source for cyber spare parts by now. Not in the sense of doing a business. It's just his personal fun. But he bought, for example, the remainings of CDC Europe. So he has about 3 CDC CPUs in part. He has basically everything you can find about CDC CPUs. And there's still a few operating over the world. So he's been approached by people to get spare parts and so on. So what we have here is a classic ADM3A terminal, dump ASCII terminal as it's been called. Standard PC Linux box over here, which is from the ACCRC, a refurbished computer. It's a AMD 300 box, works perfect fine, regular here, and it just serves as terminal server for the serial line of this one. It's hooked up to the local network, which is hooked up to the internet, which is hooked up to a DSL line in Munich. Well, or you should say the DSL line is also hooked up to the internet. Anyway, going through the DSL line in here, there is a Bull. I think it's a Bull system. I'm not sure. It's some kind of Unix system which works as a server in here, which connects then to the network of the cyber systems.
So this is a classic terminal connected through the internet to a classic machine.
Exactly. Well, this is what the internet was designed for. Not blinky pictures and hello, bye, whatever stuff. To connect on a telnet service on a real machine and do real stuff.
So what do you have here that people can do on this machine here?
Well, this particular is a demonstration how to work on an NOS machine. What we have here is a listed Fortran program. You know, Fortran, real programmers only use Fortran. Every other stuff is for wimps.
Do loops.
Yeah.
Format statements.
Yeah.
Continuation lines.
Exactly. So what we have here is the Fortran program, which calculates pi to using the Monte Carlo method, which is generating random numbers and prove if they're still within a circle or outside of the circle. You can have this program. We just listed it here. We already compiled it. You just can let it go. LGO is load, go. And now it's calculating pi's using 10,000 attempts. And we're pretty close, 3.14015. Well, it's a little bit away, but for just 10,000 iterations, it's already close. Most people don't even remember 3.14. Wasn't there a law going to P is 3?
Yes, that
somewhere
was in Tennessee.
Tennessee. So this is even way better than the people in Tennessee need. We can just run it again, LGO. We'll see it comes up with a little bit different result. Now we have 3.1437.
And so that 1.604 CP seconds execution time, is that?
Yep, that's
CPU
exactly.
time?
That's the CPU time on the mainframe.
So can you tell me something about the mainframe? Cycle time, how much memory, disk space?
Not right now. I have some of the information over there.
Okay.
Just I have to pick it up. I don't have it down from memory.
Okay.
What one needs to know is the cyber machines, the Simocray design is a little bit odd because it's made for scientific computing, which means the CPU is only the thing to run number crunching. All the data management stuff is done by separate CPUs. So basically, when you talk to the CPU, you don't talk to the CPU, you don't talk to some kind of I/O processor. And only if you have a job compiled and finished to run, then you dispatch it to the real CPU. which is even for commercial computers odd.
Yeah.
Yeah.
So does this on your sign you say its lineage is the 6600?
Yep.
So does it implement the same basic architecture?
It is the same basic architecture, of course, enhanced with better prefetch and loop interaction or whatever kind. If you should ask to John Sabolitsky, who is the owner of the machine and who really knows everything about it.
Okay.
He can go on for hours about the technology in there. But in fact, the basic CPU architecture is the same then for the 6600. And what we're running in here is really a NOS version from 1964. So it is a 1989 machine, yeah, but it is an operating system version from 1964. So really got classic feeling, just faster.
Very nice. Any last thoughts?
Hmm?
Any last comments?
No,
It's fun.
just come over, go into www.cyber- no, what? Wrong. Backspace. www.crate-cyber.org. You will come up with the website you see over here, which is the website of this project.
Mm-hmm.
This machine runs every other weekend? I think every other weekend on a Saturday, and is available for public access. Just go on the website, pick the address, mail into the people, and they give you an account and can really work your own Fortran programs on your own supercomputer.
Neat.
A lot of fun.
Thank you. Okay, rolling. So why don't you just tell us who you are, what you do, if you have a web page for your project, and then just kind of go through what you have here and what's neat about it.
My name is Wayne Smith, and I'm actually a patent attorney, and I work for Warner Brothers in Los Angeles. And my project is, or my display is an attempt to show the sort of prehistory of the IBM computer before the IBM personal computer was released in the late 1981. And in the middle here, I have the IBM 5100, which was IBM's first attempt at a small desktop type of computer. It was released in September of 1975, and it retailed from anywhere from about $10,000 to $20,000, and it was a commercial failure. On the left here, I have the IBM 5110, which was the sort of the next generation of the 5100. It was released in early 1978, about the same price range. You could get it with a peripheral 8-inch floppy disk drive, whereas the 5100 only came with a tape storage, and each tape held about 205 kilobytes. One thing that's interesting about these computers is they don't run on a microprocessor. They just run on a board level, like logic gate type of system. And then the last one I have here is a IBM System 23. This was IBM's sort of last desktop computer that was released prior to the release of the personal computer. It was also released in 1981, a little bit earlier. It was mostly a business system. It boots to a basic interpreter, and you had some business and word processing applications that it came with. So that's my display. It's sort of the history of the IBM personal computer before the personal computer.
So have you ever used any of these machines? How did you become interested in the 5100?
Like a lot of things, I was interested in. I had an early IBM PC, and the reason I became interested in the 5100 is someone had this one, and it was offered to me. It was in New Jersey, and about 5 years ago, and so I went through a lot of effort to get it and get it back to California. And so often your interest in something is developed because someone gives it to you or something. And then after I got this, I became very interested in this sort of era of IBM, and so I acquired these other machines over time.
So you taking a look at the 5110 that's over here. Do you have one that has both BASIC and APL?
No, and of course having APL is kind of the holy grail of the 5100 series. I don't. And part of the reason for that is that on this computer, APL was a $4,000 option. And I think IBM anticipated they were going to sell a lot of computers with APL, but based on the sort of fragmentary records that I've been able to accumulate about IBM 5100 owners, it looks like maybe about 20% of the computers, maybe 25% had APL. So no, I'm not fortunate enough to have one, and I only know of about 3 or 4 that are out there. So
So do you know if any of these machines are actually still in use?
no, I don't believe any of them are. I mean, just by collectors who fool around with them, their capabilities are extremely limited. I mean, the most memory you can have on them is 64K. They weren't really used like DEC machines are to, like, run elevators or things like that. And so I think it's extremely doubtful. I mean, the famous story about the 5100 is that some guy in Atlanta had bought a number of them for his business and was so dissatisfied with them that he put up a billboard in Atlanta that said, IBM sold me a lemon, and had it up for about 3 or 4 months. And that's the sort of the infamy of the 5100. So that you hear that story all the time. So, but they're fun machines to have, and you can write little game programs on them in BASIC like any computer. So they're an interesting part of history.
Neat.